Hi everybody, so these are the guided practice examples that I said in class I would send out. So for our notes, let's put example 4, guided practice. And the directions are still the same, so I'm going to just continue with our first guided practice question. And it is tangent of 5 pi divided by 3. So the prior knowledge that we want to have in the back of our minds is that pi over 3 equals what degree? If I asked you counting by pi over 3 is counting by what would you say? And my hope is that you would say 60 degrees. And just put that in a little bubble because we are not going to convert this into degrees. But the fact that I see this as dividing by 3, I know when I'm sketching, I am going to be counting by 60s. So let's sketch it together. Now, the fact that I'm counting by thirds, I want to ask myself, what are my axes values? So here, if I was counting in thirds, the question is, what divided by 3 equals 2? And that would be 6 pi. So I know if I go all the way around, I would get to 6 pi, but I don't want to go all the way around because it's 5 pi over 3. I see that it's positive, so remember, positive angle is CC, super happy, counterclockwise. Negative, not so happy, just clockwise. So positive, counterclockwise. In standard position, I always start right here. And remember, I'm not going to go all the way around because I'm only trying to get to 5 pi over 3. I also hope we kind of mentally realize now that when I'm counting by 60s, there's a 60-degree triangle located, one per quadrant. So pi over 3 would be right here, 2 pi over 3, 3 pi over 3, 4 pi over 3. Remember our 60-degree triangle looks like this. And then 5 pi over 3. So I know that I'm going to come all the way around and stop right here. And let's draw our angle. So that is 5 pi divided by 3. And if I mentally think about if I created a triangle like we did in class, it would be a short side and then long. So I'm doing my best to be accurate with my sketch. So now that I've sketched my angle and I've clearly shown I know how I got there by in one color, coming all the way around, showing where I stopped. My next step is, what's the reference angle? Remember, reference angle is the shortest angle, I keep saying shortest angle, I'm sorry, smallest angle from the terminal side to the x-axis. So I indicate I'm talking about an angle with an angle mark. Notice there's no arrows, and I switched colors to make it very clear to myself. And that is 60 degrees. I ultimately would like you to write, instead of 60 degrees, I would like you to think pi over 3, but for me, sometimes I could say to myself, well, I'm going to say 60 degrees here, but if Ms. J asked me what's the reference angle, I'll write pi divided by 3. Another way to think of it is, to get from 5 pi over 3 to 6 pi over 3, I have to add pi over 3. So this means that tangent of 5 pi divided by 3 equals tangent of pi over 3. I have to keep in mind, though, that I am in quadrant 4. That's going to affect my signs. And the reason that I will need to pay very close attention to signs is that if I'm in quadrant 1, everything is good. X is positive and Y is positive. But as soon as I move outside of quadrant 1, left is negative, and anytime I go down, that will also be negative, so that will affect signs. But we'll get there once we discuss what is tangent all about. From our new definitions this morning, instead of opposite over adjacent, we are now going to think of tangent as y divided by x. So this is the moment where we can decide about signs. So when I look in quadrant 4, ask yourself, is y going to be positive or negative? And I'm hoping we're thinking negative, because to get to any point here on this angle, I'd have to go down. So y is going to be negative. X will be positive, because if I start at the origin, I'm going right, and right is positive. So I'm all set. I've decided my signs. Now we're ready to talk about what is the y value and what is the x value. From class today, so I'm going to make another little brain bubble over here. We talked about visualizing what would the 60-degree triangle look like. So if I were to sketch the 60-degree triangle in that quadrant, here's my origin. I'm asking myself, what's the short side? That's going to be my x. And what's the long side? That's going to be my y. We discussed that the short side is 1/2. We proved that to ourselves on our homework using our properties of 30, 60, 90s. And the long side is √3 divided by 2. Going down means it's going to be negative. So literally, this is my x and this is my y. So to write tangent, that will be negative √3/2 divided by 1/2. Now we're going to step into our algebra skills to figure out how to divide these fractions. So I'm going to keep the first fraction, so negative √3/2, change to multiplication, and flip 1/2. We're going to multiply by the reciprocal. Well, that's not the reciprocal. Multiply by the reciprocal, which will be 2 divided by 1. I technically multiply straight across, but I see that the 2's can cancel, so I'll take care of that first. And that equals negative √3, and I am done. Tangent will always be the most involved, because when we're working with a 30-degree triangle or a 60-degree triangle, we'll have division like this to take care of. But if we show our work, we'll be just fine. Number 2 is sine of 5 pi divided by 6. So I'd ask that you pause the video and try sketching that on your own. Pause the video, try sketching that on your own and finding the reference angle, and then we'll see if we match. Please press pause now. So let's see how we did. If I know I'm dealing in sixths, I know that this will be 12 pi divided by 6, because that equals 2 pi. That's way too much. So then I ask myself, well, what would be over here? That would be 6 pi over 6, which is way closer to what I'm looking for. Remember, whatever's here on this part of the x-axis should always reduce to pi. The fact that this is positive, I remember I'm going to go counterclockwise. So starting right here, I'm going to go, and I know that sixths is counting by 30 degrees. So if this, I'm just going to pause right there. If this is 6 pi over 6, and I'm trying to get to 5 pi over 6, it means I need 1 less pi over 6 than 6 pi over 6. So I'm going to visualize stopping 30 degrees short. And that's still a little too far. You don't want to make it look like a 45 degree. So I'm going to go even just a little more. There we go. So there is 5 pi over 6. Now that I've drawn my angle, I want to ask myself, what's my reference angle? What's the shortest distance from the terminal side to the x-axis? And there's two ways to think about it. I could think to myself, well, I know pi over 6 is 30, and I'm 1 pi over 6 away, so this is 30. Or you could say, well, this is 5 pi over 6. To get from 5 pi over 6 to 6 pi over 6 is pi divided by 6. So some people may have written pi over 6 here, some people may have written 30 degrees. You're both right. Just make sure that when you tell me the reference angle, you go back to radians. So my reference angle is pi divided by 6. That means that the sine of 5 pi over 6 equals sine of pi over 6. From class, we know that sine is connected to y. So I'm going to commit right before I move any farther. I'm going to say, what is sine in quadrant 2? So anywhere in quadrant 2, if I move vertically, that's moving up. So I know that this is going to stay positive. Now I ask myself, what is sine of pi over 6? So again, I'm going to create a little bubble, like a little brain bubble here. And I'm going to ask that you literally ask yourself, first of all, what triangle do I have? I have a 30-degree triangle. This is my little brain bubble. This is 30 degrees. Ask yourself, if I'm dealing with sine, do I care about the long side or the short side? And the answer is short side, because that's opposite 30. Sine is opposite 30. For us on the coordinate plane, that's y. From our work with our 30s, 60, 90 triangle, I know that this is going to be a half. So that means sine of pi over 6 equals 1/2. So before I do the last example, I want to emphasize, for right now, if drawing these little triangles in little brain bubbles helps you out, I'm totally cool with that. So that it helps to make concrete, whenever you're dealing with 60 degrees, what is short, what is long. Short being cosine, long being sine. Because across is the opposite. Opposite is always y. Adjacent is my x. So short side, long side. Same thing down here with the 30-degree triangle. Opposite is the vertical, the y side. Opposite 30, short. Adjacent, which is going to sit right on the x-axis, this would always be root 3 over 2. So if I had asked you for the cosine of pi over 6, I would think to myself, cosine, adjacent side, x-axis, long side. All of those things come to my brain, and I say cosine would be the long side, which is root 3 over 2. So if sketching these triangles helps, do that until it's concrete. Until when you see this, you're thinking this. So let's look at our last example, number 3, which is secant of negative 135. So as always, please press pause to sketch. And then we'll see if we match. So I know I'm moving in a negative direction. Negative is not so happy. It's just clockwise. Which means this is 0 degrees. If I'm moving clockwise, here's negative 90. Here's negative 180. So I know for sure I'm going to be in quadrant 3. I start traveling. Here's 90. 135 is halfway. A kind of a giveaway is that 135 is pretty close to 140, so halfway. Now that I've sketched negative 135, I ask myself, what's the reference angle? What is the shortest distance from the terminal side to the x-axis? Ignoring the negative sign, the distance from 180 to 135, or 135 to 180, however you would like to see it, is 45 degrees. So I know that the secant of negative 135 is equal to secant of 45. Now secant is one of our reciprocal functions. It's connected to cosine. So in my little brain bubble, I'm thinking cosine of theta in general is x divided by r. So secant is going to be r divided by x. If I'm from the origin traveling left, x is going to be negative. The radius is always 1 when we're on the unit circle. And what is the x length? So visualizing my 45, 45, 90, if I were to create a triangle in that quadrant, I am visualizing, see how it kind of makes that shape? Here's 45. From my homework, I know that my radius is 1, my hypotenuse is 1, and this is root 2 over 2, root 2 over 2. In this case, it would be negative and negative if I were to create the triangle here in quadrant 3. So coming back up, r divided by negative x, that's going to be r divided by a negative root 2 divided by 2. So now let's work on the algebra to finish this. Remember, we don't actually divide fractions, we change division into multiplication. So I'm going to keep the 1, change division to multiplication, keep, change, and then flip that fraction I was dividing by, multiply by the reciprocal. 1 times anything is just itself. So now I've got to say, well, I got 2 divided by negative root 2. But no good, because we don't keep radicals in the denominator. So to rationalize, I will multiply by root 2 divided by root 2, which equals 2 root 2 divided by negative 2. My 2's cancel. That leaves negative root 2 as my final answer. So that finishes the guided practice examples. To be super clear, the homework for tonight is 4.3, page 251. Did not mean to change the slide on you, sorry. Numbers 25 to 32, odd. Those should all definitely be doable. And then from the next set, which is 43 to 58, you should be able to do just about all of those. If there's one you're like, yeah, I don't know about that one, at a minimum, every single one of these should be sketched. So definitely come in with your sketches. If you're not sure how to move forward, no problem. We'll talk about it. But when you come to class, I'm going to have you compare your sketches with everybody. So if you don't come in with sketches, you're not going to be able to check with someone. As you're working, always remember, you can send me a question on Remind. Hope this goes well for you, and I will talk to you soon.